search in rotated sorted array from LeetCode. Let's jump to the question. There is an integer array nums sorted in ascending order. So we have an array of integers sorted and it's in ascending order, and we have distinct values. Given the array nums, after possible rotation and integer target, return the index of the target if it is in nums, or -1 if it is not in nums. And we should do it in logarithmic time complexity. So whenever we are talking about logarithmic time complexity and finding an item in an array, the first thing comes to my mind is binary search tree. And the question is saying an array is given and there is a possible rotation. So it means we might have a rotation in the array or we might not have it. So as you see in this example, we have a rotation in this array and we don't know where at what index we have that rotation. And we are looking for target value 0. So what we are going to do, we are going to return the index of the 0 in this array. And in case if the target value does not exist in the array, we are going to return -1. And in this example, you can see the same 0, it doesn't exist, so we are going to return -1. Let's jump to the solution and see how we are going to solve this problem. So let's we have this example, the array nums, and the target value that we are looking for is 0. The first thing first, we are going to deal with the special cases. When there is no nums, when the array nums is empty, what we are going to do, we are going to return -1, because no matter what, the array is empty, so we cannot find the target in it. And as I said, we are going to use binary search tree, so we are going to use 3 pointers. One pointer, we are going to set the left pointer and right pointer. Left pointer is pointing at the beginning of the array and right pointer is pointing at the end of the array. And we go through a while loop, and as long as the left pointer is smaller or equal to the right pointer, we keep iterating over the array until we find the target value, or if the target value doesn't exist, we are going to return -1. And what we are going to do here, we are going to calculate mean by sum of left and right array divided by 2, which is going to be at index 3 for this case. And we are at the beginning, we are going to see if the value that we had at nums mid is equal to the target value, and if it is, we're going to just return the mid. And if not, we are going through these if conditions here. So what we are going to check, we are going to see if the value that we have at left is smaller than the mid. So that means it's in ascending order and rotation point is not here. So that's what we are going to check. And if the left value is smaller than the mid value, what we are going to do, we are going to check to see if the target value is between these two pointers, if it is between left pointer and right pointer. And if it is, what we're going to do, we are going to move the right pointer to mid -1. So because we know it exists between these like this scope, and if not, we are going to move the left pointer. So as you see, the left value that we have here is 6, and the mid value is 9, and the target value that we are looking for is 0. So 6 is not smaller than 0, and 0 is not smaller than 9. So so this is not the right condition. So what we are going to do, we are going to move the left pointer to mid +1, because that means the value that we are looking for is not going to be between these scopes. So we keep iterating over this array and we make smaller scopes until we find the target value, or we are done with the array. So we are going to move the left pointer to mid +1, and then what we are going to do, we're going to check if the left pointer is smaller than the right pointer. 4 is smaller than 6, so we are going to calculate the mid, which is going to be at index 5, and we check if this is the target value and that is the target value, and we're just gonna return mid as a result, which is going to be index 5 for this example, right? And let's see another example. In this example, we have a rotated value, it's just one in the one item here, and we have this, and we are looking for 0. What we are going to do is it's going to be the same. We have a left pointer and right pointer. and this is going to be the left pointer, and this is going to be the right pointer that we have here, right? And what we're going to do, we are going to find a pointer. So this is 1, 2, 3, 4, 5, 6, 7 items that we have here. So we are the 7 plus 0 divided by 2 is going to be 3. So the mid pointer is going to be at this point. This is going to be the mid pointer. What we are going to do, we are going to check if this is a ascending order. So we check if the value that we have at pointer L left, which is 9, is smaller than mid, and it is not smaller than mid. So this means it's not an ascending order, and we might have the rotation point here. So what we are going to do, we are going to check if the mid value, which is 2, is smaller than target, and 2 is not smaller than target. So what we're going to do, we are going to move the right pointer from where it is to mid -1. So this is what we're going to do. We are going to move the right pointer from here to here. And now we calculate the mid. Mid is going to be here, and we check the mid again. We see if the left pointer is smaller than right pointer, and it is, and we check if the left pointer is smaller than mid, and it is not. So what we're going to do, we are going to check if the mid value that we have, which is 0, is smaller or equal to target, which it is, and we are going to return 1 as the answer. As you see, we are not using any extra spaces, so that the space complexity is going to be constant, and because we are doing the binary search tree with just one iteration, it's going to be logarithmic. Thank you.